Okay, we're going to start with going back over some more on precipitate reactions. And then we're going to talk about limiting reactants and percent yield. Just because we mix two ionic solutions together does not mean a reaction is going to occur. So if we had Ki and we mixed in an aqueous solution and NaCl in an aqueous solution, and just to make sure, these letters right here in parentheses here just tells us its state. Aqueous means it's in a water solution. L means it's a liquid. S is a solid. G is a gas. So to predict, we predict K will Na and Cl. So we predict that these will change. So potassium chloride plus sodium iodide. Neither one of these, if we go back to our solubility rules from last time, because potassium and sodium are both soluble, with this not being an exception and this not being an exception, means that we have nothing that's insoluble. So basically these ions just stay free in the aqueous solution. So there is no reaction here. So to predict a reaction, we look to see whether or not they are both soluble or insoluble. Okay, to figure out our possible products, we're going to list our cations on one side. In this case, it would be potassium and nickel. And then we're going to list our anions on the other side. Nickel would be +2. And chlorine. Well, if these are the ions that we have in our aqueous solution, then the potassium can pair with this one or this one, and the nickel can pair with this one or this one. Well, we started with the KCO3, so our possible products are KCl and NiCO3. Now, if we go back to our solubility rules, remember, basically anything with potassium is soluble, so this one is soluble. Anything with CO3 is insoluble, and nickel was not an exception. So this one is insoluble. So this reaction occurs, and this would be our precipitate. If we look at the next one, we have Na and Na and lithium. And then we have NO3 and SO4. So we're going to have lithium, NO3, and sodium. Now lithium is soluble. Compounds with NO3 are soluble. Our exceptions, lithium is not one of our exceptions, so this one is soluble or insoluble, or soluble, I'm sorry. This one is soluble. I said it right the first time. And then anything with Na plus is soluble. Therefore, this one has no reaction. Okay, we're going to talk about a couple of different ways to look at this information. This is called the molecular reaction. This is how we've seen it in the past. But we have talked that in an aqueous solution, we don't necessarily have potassium iodide as a compound. The potassium and the iodine are both mixed into the aqueous as independent ions, and they're each attached to different parts of the water molecule. Uh, so another way to look at this would be potassium plus iodine plus lead plus NO3 yields okay, so it yields K plus nitrate plus P lead iodide. Because this one is insoluble and it's the solid, then it gets to stay together. These that are left, these are our spectator ions. They did not participate in the reaction itself. So these are our spectator ions. So this is the ionic equation. And now the net ion equation takes out the spectator ions. Therefore, it looks like Pb plus I negative yields PbI2. So the net ionic equation takes out the spectator ions. The spectator ions are the ones that do not participate in the reaction. They're the ones that stay soluble in water. Okay, so limiting reactants. If we talk about a pizza, if I know that my pizza takes, the recipe says I need 1 crust, 1 cup of sauce, and 15 pepperonis. And to make 1 pizza. So if I have 4 crusts, how many pizzas can I make? And the answer to that would be 4 crusts. We said that there's 1 pizza to 1 crust. So I can make 4 pizzas. If I had 3 cups of sauce, now let's say I have 45 pepperonis. I said we needed 15 pepperonis for 1 pizza. 40, so I can make 3 pizzas. So our limiting reactant is the one that means I can make the least. So I can only make 3 pizzas. So in this case, pepperoni is my limiting reactant. So let's apply this to chemistry. If we have this reaction, methane plus oxygen yields carbon dioxide and water. If we start with 5 mole, and it is balanced, we have it balanced already. So if we start with 5 moles of methane, so I have 5 moles of methane. How much carbon dioxide can we have? Well, methane, it's 1 mole to 1 mole, so 1 mole of methane of CH4 is going to yield 1 mole of CO2. So this is going to make 5 moles of CO2. If I have 8 moles of oxygen, so 8 moles of oxygen, and we had 2 moles of oxygen makes 1 mole of CO2. 2 moles of oxygen makes 1 mole of CO2. Then we have 4 moles of CO2 being produced. So in this case, oxygen is our limiting reactant because it will only make 4. And the one that we have a larger number of is in excess. We have extra. If we start with grams, and this is when our math starts getting a little more entertaining, if we start with 32 grams of CH4 and 256 grams of oxygen, which is our limiting reactant, well, we have to convert our grams to moles first. So we start with 32 grams of CH4. So carbon is 12, hydrogen is 1 times, there's 4 of them, so CH4 should have a molar mass of 16. So 1 mole of CH4 equals 16 grams of CH4, so this would be 2 moles. 2 moles of CH4. And then for oxygen, oxygen we know is 16. There's 2 of them. So 16, so we're starting with 256 grams of oxygen, 32 grams, and that should be 4. Okay, so 256 divided by 32 equals 8 moles. So our limiting reactant is the methane, the CH4. Okay, so how many grams are we expecting to be produced? Our prediction from the last slide said that we're expecting 2 moles of CO2 to be produced. So if we have 2 moles of CO2 to be produced, carbon is 12, oxygen is 16 times 2 is 44. We said that we're expecting 2 to be produced. So 2 moles So we're expecting 88 grams to be produced. However, we only have 22 grams produced. So how do we figure that out? So what we're going to do is we're going to take the amount that we got, so 22 grams, divide it by our theoretical yield, which should have been 88 grams. And that is going to equal 0.25 times 100%. So we had a 25% yield. So to determine your theoretical yield, you calculate based on the stoichiometry, and then to get your percent yield, it is the actual divided by the theoretical times 100% gives your percent yield. Okay, we already said that had a mass of 16, has a mass of 32, has a mass of 44. Okay, so if we start with the 32 grams of CH4, so that's 2 moles of CH4. So 2 moles of CH4, and it is in a 1-to-1 relationship. And yes, we know that if it's in a 1-to-1 relationship, it should be the same. However, I stress that because of the test, they need to be able to follow your math, that you make sure that you go ahead and write it out so that they understand that you understand. So 2 moles of CO2 will be produced. And then oxygen, we said oxygen had a mass of 32. We have 128. It should be 4 moles of O2. And so 4 moles of O2 and it is in a 2-to-1, so 2 moles of O2 of CO2. In this case, neither one of them is a limiting reactant. They both produce the same amount. Okay, y'all get to practice this one and tell me, there's a couple of different ways to figure out parts of this one. So come up with a way to do it, and we will discuss it at the end of class. Thank you and have a great day.